So we can start now. So today's session 2. Yesterday we have discussed environment setup, and then we have created one simple EC2 instance, and we have seen how can we use Terraform commands like Terraform init, and then Terraform plan and Terraform apply. Okay, and we discussed the advantages of Terraform. Okay, over manually created infrastructure like version control, consistent infrastructure from dev to production, and automated creation of infrastructure, updation, and then deletion. And we can see the inventory using Terraform files. How can we reduce the cost and dependency management, modular infrastructure? So all these advantages you will slowly understand by end of the course. Okay, we can justify it through our practice and experience. For now, take it as granted. We'll experience this soon. So today agenda is about 3-tier architecture, and then one real-time assignment. So to implement Terraform, we need some requirements, right? So recently I attended an interview with one of the US company, topmost US company. So they have given me one assignment. Okay, it is open. No worries, I can share. So what this is the task they have given me. Okay, so what they are expecting is to deploy one 3-tier architecture. Deploy one 3-tier architecture application into cloud environment. And entire project infra should be created by IAC. Okay, infrastructure as a code like Terraform. So this is the assignment. Actually, I can keep it in the GitHub as well. So this is the major part of. You need to create the resources for all tiers. The architecture should be completely provisioned via some infrastructure as a code tool. Okay, it should be self-healing and then automation of recovery. And they asked me to deploy in any cloud like AWS, Google Cloud, Azure, DigitalOcean, and anything. Okay, and so this is the requirement. Actually, I can share you through this. And at the end, they asked me to share the architecture diagram, everything. So this is almost the real project application, whatever we are using in our projects. Okay, first our goal is to complete this. They also asked me to make it as production implementation. Don't take it as silly application. Consider this as a production application. Create the infrastructure, deploy the application, automate everything. So this is what they told me. Okay. So we will take it as a proper requirement, and then we will complete it by end of the course. And on top of it, we will take one real-time project from IBM. First, when we complete this, then it will take very less time to complete the IBM project also. Okay. So before that, I need to explain you what is 3-tier architecture. So nowadays, every application is through the website. Okay, even we are using mobile apps that follows the 3-tier architecture. 99% of the applications in the world comes from the web applications. So web applications, a simple example I'll tell you. Okay, what is 3-tier? So if you go to any roadside hotel, right? So generally, if we go to any roadside hotel, maybe one cart, so there will be only one person. We go to them, and if we ask for one dosa, so they are taking care of everything. They are cooking, they are taking the order, and they are taking the bill. Everything is handled by one person. Okay, so this is a good example. Actually, I used to say one street shop, for example. So one person is taking care of all the responsibilities. He's cooking, he's taking order, and then he's taking the billing. So all the responsibilities he is taking. He can handle at a time maybe 3 or 4 persons. Suddenly, if a crowd of 100 people came to him, then he is not able to manage. So then what he do is he will have one more employee to take orders and billing. Okay, now he can only concentrate on cooking. So this is small shop. This is medium shop. But when you enter the restaurant, there will be one person greeting us. He's called as captain. He greet us, and what he do is he will check the tables. Which are free. And he will direct us to sit in the table. Then waiter will come. He will take order and hand over to chef. Okay. So finally, the process is chef responsibility is only cooking. He takes some raw items and cook them into eatable format. Okay, so that is the only responsibility of chef. If you ask him to do the extra responsibilities like order management, queue management, then definitely he cannot concentrate on the cooking. So in restaurants, we want only chef to concentrate on cooking. Waiter is queue management, right? Or order management. And captain is queue management. Order and bill management. Okay. So if you have these many persons, they can completely concentrate on their only special responsibilities. If the number of persons are reduced, they cannot concentrate on the on their own responsibilities. Similarly, in a web application, generally we have 3 tiers. Database is 1 tier. This is database. Where all the users data. Whenever I open facebook.com, right? So facebook.com is taking our email address and then it is taking our password. Then when we click on login, what is happening here is first a website is there. Front-end website. Mostly HTML and JavaScript, either React.js or Node.js, whatever the JS. So this is the front-end website. So what this front-end website, it will take the data from us. Okay, like username, password, and if you create the new account, it will take your first name, date of birth, all these details. It will take all these details. And what it does is it will send it to one backend website. This is usually Java, PHP, Python, .NET, Node.js. So these are the backend programming languages. So front-end is HTML and JavaScript. It will send the request to the backend programming languages. Then these backend websites will connect to the database. For example, if you are signing up for the first time, this front end took all the details and send these details to the backend. And this backend will do some will do some validations like, is this person already exists in our database? Okay, maybe the mobile number, so the email address is already exist in our database. If it is exist, then it will throw the error. User is already exist. If it does not exist, then it will go and save the user, it will create the account, then it will send the response to the front end. User creation is successful. Okay, so this is called three-tier application: front end, back end, and database. Okay, so Java also can behave as a front end also. In Java, you can develop both back end and then front end, you can keep it. But as I said, if you hand over the responsibilities to the one person, he cannot concentrate on his priority tasks. Okay, so that's why what we have done is we connected front end and back end through the API. Okay, so it will receive the details and then it will send the request to the backend, then backend will respond. So this is the three-tier architecture generally: front end, back end, and database. Front end tier, back end tier, and then database tier. And in front, generally we have something called as load balancer. Okay. So this load balancer also you can consider it into web tier. It has multiple names like web tier or front end tier. And this we can usually call it as app tier or backend tier. This we call it as database tier. And sometimes we call this as middleware also. Okay, this load balancer is just to balance the load. You can consider him as captain, waiter, and then chef, and these are the raw items. So now chef is taking the raw items and then he is making them into some understandable format like HTML and sending it to the front end. So that is what is happening here in our web applications. Even you take any Android app is a front end here, and in background they are hitting to web services like Java or PHP, Python, or any backend languages, and those APIs will give the response to the Android front end. Okay, so this is the three-tier architecture. So nowadays every application like Amazon, Netflix, and then Prime, all the popular applications in the world are three-tier architecture implementation. Okay, so if you understand this, then we need to provision the infrastructure for this three-tier application. Okay, so in this assignment, what we got is, so they gave me some website code that is okay. So this is the website usually. So I will tell you, but for now I cannot run this. Okay, this website, when you hit this website in this, it what it does is it will show you the time. Okay, the time from where it gets the time is from the database. For example, this is Postgres database. In Postgres, there is a table, something like a table called time. So this is Node.js backend, and this is also Node.js. Remember, Node.js can be used as both front end and back end. Okay, so this website will call this app, and this app will call the database and fetch the time from the database. Okay, so that is what here. So this is the front end code, and the back end code is this one, API. Okay, finally, we are going to deploy this application into cloud. This is the three-tier architecture. To deploy three-tier architecture, you need to have some infrastructure. Something like database, VPC, Route 53, and load balancers, ALB, and then what else we have? Certificates, okay, CDN. So we need many more services as an infrastructure. So first infrastructure is like project infrastructure. We need to set up the base. Once you create the infrastructure, then only we can deploy the applications, right? So usually we deploy the applications into the infrastructure, like any EC2 instance or Kubernetes, Docker and Kubernetes or Elastic Container Service. All those things we need to make them ready. Okay, so first we need to set up the infrastructure, that is called project infrastructure. VPC is the base for each and every. VPC is the first base for any cloud infrastructure. VPC is nothing but virtual private cloud. We can say equal to on-premise data center. So generally, without cloud, maybe 10 years back, so what we had is we have a data center in on-premise. And we have a subnet. VPC generally subnet, and then routes, route tables, all these things we will have. And then network connection. So when an application team wants to deploy some application, what they request from the infrastructure team is they want servers. Okay, and databases, database servers. So all these things will be requested from application team. Then this infrastructure team will go and create the servers in this VPC. Okay, so VPC is called as virtual private cloud. So for one project, ideally, you can create one VPC, and this VPC is isolated from other projects. So VPC is usually a mini cloud isolated from other projects. Okay, so inside VPC, you will have subnets, routes. Internet gateway is nothing but network connection. Yeah, so this is the VPC usually we need to create for any project in a cloud. Okay, virtual private cloud. So I hope you all know basic details about the VPC in AWS or any other cloud. Okay, because every project will have one VPC, and project A VPC is different from project B VPC. So now what we do is we will create one VPC now here manually, then we will automate it. While automating, we will understand the concepts of Terraform. Okay, so here I'm creating one VPC, for example, manual VPC. And you need to select the range of IP address, generally 10.0.0.0/16, and create VPC. So that's it. VPC is created. This is very easy in cloud. Okay. And once VPC is created, we have subnets. Why we should have subnets is this is a project, for example, VPC for project A. So every VPC has different teams, like there is HR team. And for every project, there is another team called sales team. There will be marketing team. So one project has multiple teams, right? And then development team, testing team. So everybody has their own applications. Sales team has their own application. and HR team has their own application, marketing team has their own application. We need security. HR person should not access marketing. Okay. And then salesperson should not access development, but sales team can have the marketing. Okay. So this can be, so this connection should be success, because sales team should have some data from the marketing team. So sales team should access the marketing data, but HR team should not access. So these kind of access restrictions should be implemented. So for that purpose, what we have is subnet. So HR will have their own subnet, sales will have their own subnet, and marketing will have their own subnets. So HR related applications we will only create in this HR subnet. Sales related applications we will only create in this sales subnet. If sales team comes to us and then they ask for the access of marketing, then we can give the access. And tomorrow, if they don't want to access, then we can remove the access. So this is possible in cloud infrastructure. Okay. So for that purpose, we need to create here subnets. We need to select the VPC, and first subnet I am going to create. And security wise, there are two subnets. One is public subnet and private subnet. What is public subnet and private subnet is, public subnet apps can get traffic from internet. Okay, applications in public subnet, if they are able to access over the internet, then it is called public subnet. Private subnet apps cannot get traffic from internet. These are only for internal purpose. Okay. For example, when you go to bank, cashier will be accessing one application. That application is not available for us. Then it means it is hosted in private subnet. And we are opening HDFC net banking. It is available for public. So then it is launched in public subnet. Okay. That is the difference. So first I'm creating public subnet. You can create based on HR subnet, sales subnet, like that as well. Okay. So, and you need to select the availability zone. So every region will have multiple availability zones. For example, Hyderabad North will have one data center. Hyderabad South will have one data center. Because in North, if some natural disaster occurs, then still applications can work from the South. So that's why we have multiple availability zones. At least 2 availability zones will be there for every region. For example, I took 1A, and here I'm giving it as 1.0/24. Okay, CIDR is a big concept actually. I hope you know it already. Okay, otherwise generally I will keep some videos in YouTube. So this is public subnet, and I will create another subnet called private subnet. And you can create in any availability zone. Okay. 10.0.2.0/24. So generally what is the flow is, first we need to create VPC, then we can create subnets, and we need to create internet gateway. Internet gateway is nothing but a modem. For example, you have your home internet, like you connected mobile phone, laptop, and then other devices like Wi-Fi accessible devices like refrigerator or desktop, anything. But how you will get the internet access is through the modem. So modem is equal to internet gateway here. Okay. I can say manual internet gateway. So, and this gateway should be attached to our VPC. So it's nothing but here there is a VPC and there will be a modem. And these two are connected. And this modem, you can access the internet. So internet gateway is nothing but to access the internet. And you should attach this to the VPC. Okay. Then next is route table. You need to create some public route table and attach the VPC. See, public route table is nothing but I'm editing the routes. I'm adding the internet gateway. So if you attach internet gateway to any subnet, then it is called public subnet. As I said here, public subnet apps can get traffic from internet through internet gateway. Okay, so now I created route table. I need to add this route table to the subnet. Okay, since this is public, I will remove this private. Sorry, I will attach public subnet to this public route. And now I will create private route. Attached to our VPC, create route table, and then subnet associations. Now you need to notice I'm not adding any internet gateway. If you don't add internet gateway, then it is called as private. You'll get this question. What is the difference between public subnet and private subnet? How you identify? Public subnet will have the route attached to the internet gateway. Okay, you can see here, public subnet, and go to the route table, and you can see route is attached to the internet gateway. It means a modem is attached, but private subnet, it will not have the internet gateway attached. You can see here, there is no internet gateway attached. Then it is called as private subnet. So that is the difference you need to tell them in interview. Okay, but how, for example, I launched EC2 instance in private subnet. How can it get the packages installed from internet? Okay, so the answer is it is NAT gateway. Okay, so there is something called NAT gateway. A simple difference here is you cannot reach private subnet instances. But if traffic is originated from private subnet, then it goes through NAT gateway. So a simple diagram I'll explain here. So this is VPC, and here we have public subnet, and there is a server running inside this. Okay, and we have the modem attached. It is like internet gateway. Anyone from internet can access this EC2 instance through modem. Okay, this is public. When it comes to private, there is a server inside. We cannot access from outside. Okay, private instance can access the internet. Now you need to carefully understand this point. If traffic originates from the instance, okay, then it goes through NAT gateway, something called as NAT gateway. It goes through NAT gateway, then it goes to internet and it goes to outside. You need to understand traffic should be originated from the instance. Okay. You cannot reach from the other way. You can only access from the instance. You can access the internet, that too through the NAT gateway. So we need to create one NAT gateway here. And it should be in public subnet. And you need to allocate one static IP, create NAT gateway. So this is the VPC infrastructure generally if you create it manually. This NAT gateway will take some time. And you need to add the private subnet route here to the NAT gateway. So now I'll explain once again. Public subnet will have the route attached to the internet gateway. Okay, so that public can reach the applications through internet. But private subnet will not have internet gateway. It will be attached with NAT gateway. Okay, so NAT gateway means instances can access the applications here inside the servers, can access the internet. Okay, but you cannot access from other side. That is the only difference. That is through NAT gateway. You will get this question. Then how can your instances in private subnet can get the update from the internet? Then you should say we will have the NAT gateway attached to the private subnet. Will take few minutes actually. So this is the basic infrastructure creation through VPC. Okay, first thing is VPC. You should have your VPC ready. Then only you can launch the instances. Now, yeah, it is available. Just notice NAT gateway should be in public subnet. Okay. Then you come here and go to the private subnet and go to the route table, edit route table association. Oh, sorry. Route table, click the route table and routes to add the NAT gateway. For public subnet, the route is attached to the internet gateway. For private subnet, then the route is attached to the NAT gateway. Okay. So here what I can do a simple modification is This NAT gateway is in public subnet. Within VPC, anything can access. Okay. And this go here. If you see here in public subnet or private subnet, this is local 10.0.0.16. It is local. So this private subnet can access public, public can access private. So that's why this private subnet is connecting to the NAT in public, and NAT is going through the internet gateway. So this is how you will create the basic infrastructure. This is the VPC creation for any project. Okay. So all these things we need to create through the Terraform. Now you can see this, right? We should follow a simple order. First, we need to create VPC, then internet gateway, then subnets, then route tables, and then routes, NAT, and associations, elastic IP is nothing but static IP. So all these things we need to create one by one. Now it took around 20 minutes for us to create. This is time taking and you need to follow specific order. But if you do it through the Terraform, you can do it easily. Now that is what we will see here. Okay, I'm creating one folder called VPC. And here I will add the provider. Provider is very important. Inside VPC, I'm going to add vpc.tf. So now let us go to the documentation. Terraform VPC. AWS VPC, and you can check here. So this is the syntax. Resource is AWS _ VPC. You can name it as anything. Okay, this name belongs to only Terraform. Only Terraform. Only Terraform purpose. Okay. And then here CIDR block. And then instance tenancy default. This is the default setting. Tags. Now here you can give the name. Okay, we can name it as something like automated VPC. Okay, this name belongs to AWS. So why I created another provider? Every folder you are maintaining as Terraform. Now I will go here, cd VPC. Here I will run the Terraform commands. Okay. For example, here I will go to cd VPC. Wherever you run Terraform, you should have the provider.tf available. Okay. Now I am running the Terraform command inside VPC. So I should have here provider.tf. Okay. Now that's it. Now, as I said, Terraform init to initialize. So Terraform initialize is done. Terraform plan. It is saying we are going to create one VPC. Okay. And then Terraform apply. Now it is saying, now it is asking for a permission. Then I'm telling yes. Now it is saying it is completed. Just come here. Then check VPC. Okay, we are using Hyderabad, right? For automation. Okay, here automated VPC is created. So after VPC, what we need to create? Subnet. So here you need to understand subnet depends on VPC. You can't create subnet without VPC. Okay. That is the dependency. Subnet is dependent on VPC, Terraform subnet. Okay, so this is the syntax. Resource, AWS subnet, you need to give one name, and then you need to give the VPC. Okay. Now let us go here. Within the same file we can give, or subnet.tf also you can give. AWS VPC dot main dot id. So what it does is it will fetch VPC ID created from above code. Okay, so generally, even you keep this here. Okay, assume Terraform will start running this one. Then it will see VPC equal to AWS VPC dot main dot ID. Then it will understand, okay, I am depending on AWS VPC. So I should run this first. Then it will run this one. And it will fetch the ID, VPC ID created from here, and it will hand over to the subnet. Okay. So this I am giving it as public subnet of automated VPC. You can give any name. Okay. So Terraform will come here and then it will check. It understands the dependency. It is on AWS VPC. Then it will create this first and it will get the ID from here and hand over to the subnet. Okay. Now you run Terraform plan. It is saying one subnet is going to be added. Now you just say Terraform apply. Yes. Okay, it created. Now you can check public subnet automated PVC is created. Now I will create another VPC, another subnet that is private. So order is no need to be worried about the order. Okay, so Terraform will take care 2.0 and I will name it as private. Again, come here and then say Terraform plan. Okay, so it is saying main is already used, but I will name it as private. Okay, here I used already main. So you should not use for the same kind of resource, same name you should not use. Because AWS subnet, we are creating two similar kind of resources. You should have different name here. Otherwise, Terraform cannot differentiate. Okay, now you can say Terraform plan. Terraform apply. Now it is done. Private is done. And next thing we can create internet gateway. Okay, so this example of VPC creation, I want you to understand how to create the syntax, how to refer the documentation, everything. Okay, this is the dirty way of creating infrastructure, but this is the basic. Once you understand the basic, then we go for the advanced topics. Okay, first let us write something and let us understand how the Terraform syntax is working and how can we run the commands of init, plan, apply, how can we create the basic VPC, then we can get into the actual Terraform concepts. Okay, we can improvise this Terraform in advanced level. I just want you to understand the documentation. How can you get documentation and write it on your own? So as example usage, just copy this. AWS Internet Gateway, like automated Internet Gateway. I'm naming it like this. Resource type is this one. And again, you can see Internet Gateway depends on VPC. I'm creating, I'm giving this name, same name. Again, same Terraform plan. Terraform apply. Yes. Okay, now Internet Gateway is done. Okay. After Internet Gateway, we need to have route tables. Again, same come here. Terraform AWS route table. Just copy this. I'm just giving it as public route table. Okay. And this is also depends on VPC. Okay. And then route. 0.0.0.0/0. This is the public internet, right? And now it should have the gateway, AWS Internet Gateway dot automated igw.id. So then what will happen while creating this resource? Then Terraform will go and fetch the internet gateway created here, and then it will attach to this route. Okay, just we need only one route. Name we can give it as same public route. Okay. Now let's go and run this. You can directly run Terraform apply also. You don't need to run Terraform plan every time. But running Terraform plan is good best practice. Now you come here and then check like this public route. Similarly, let us create private route also. You can check here. Internet gateway is already attached. Private route table. And you should remove this one. Okay, we don't attach this. So before this, what we do, we will attach the NAT gateway. So private route table is dependent on NAT gateway. Let us create AWS NAT gateway, Terraform. Private route table is depends on NAT, and then NAT depends on Elastic IP. Okay. So then first we need to create Elastic IP. While creating in the console, what I did is I created here itself. If you click this button, then you will get the Elastic IP by default. But using Terraform, we need to create it manually. Terraform AWS Elastic IP. That's it. Get this Elastic IP. I'm giving it as some name, Auto Elastic IP. Elastic IP, what is required? Thing is required actually. Don't need this one. It's also optional. You can remove this one also. Okay. Come here and you then check Elastic IP. But now nothing is there. Let me come and remove this one. I'm creating Elastic IP now. Just come and Terraform apply. You can see one IP is created. Elastic IP is nothing but I'm reserving one static IP. That's it. After Elastic IP, then we create NAT gateway. Terraform AWS NAT gateway. Sorry. NAT gateway. This is the syntax. Okay, you can see it is asking the AWS EIP and auto EIP dot ID. It is fetching the Elastic IP. Then subnet. So NAT gateway should be in public subnet, right? So AWS subnet dot, where is this public subnet? It is main. So usually you gave it as public generally, okay? But I gave name already as main. So just copy it as main only. Dot ID. Then it is naming it as automated NAT and depends on. So depends on is nothing but explicitly you can mention first NAT gateway, first internet gateway should be created So when the Terraform says this depends on explicitly, then it understands AWS Internet Gateway of automated IGW should be created first. Why? Because NAT gateway goes through Internet Gateway only. So that's why we are mentioning as depends on explicitly. Okay. Generally no need while creating NAT gateway, but internally NAT gateway uses this internet gateway. That's why I'm mentioning, we are mentioning as depends on explicitly. Okay, you can check here. To ensure proper ordering, it is recommended to add explicit dependency on the internet gateway for the VPC. Here you no need to add because Terraform can understand it automatically. In some, when particular cases, there are few particular cases, Terraform cannot understand the automatic dependency. At that time, you can add this depends on explicitly. Okay, so that's what here we does. Here we do, that's what here we do. Now you go and apply again. Yes. Now it starts creating NAT gateway. Okay, after NAT gateway created, then let us go and create private route also. Here it is not for private route. We don't attach internet gateway. We attach NAT gateway. Okay. VPC is then created, and here instead of AWS Internet Gateway, what you need to do is AWS NAT Gateway dot. I just gave it as example only here. Example dot ID. That's it. And name it as private route. It usually take 3-4 minutes. Now it is done. Now let us apply for private route table. Okay, it is created. Now you go and check the private subnet, go to the route table and route table, and you can see here the routes. Subnet. Okay, what happened? Public subnet and then route table, and this route table should be attached to subnets actually. This one. So we created subnets actually, but we didn't attach the association. So you need to attach subnet, public subnet to the public route table. So there is another resource like route table and subnet association, Terraform. Okay, here it is called association of route table and then subnet. Just take this AWS route table association. I'm just saying it as public subnet ID, AWS subnet, public subnet name as main, and route table, AWS route table. What is the public route table? Public route. Okay, I'm attaching public route table to the public subnet. So this association, you should manually run it in Terraform generally. In console, we select. You remember we selected. Okay, now you come here and then refresh. You can check the route table. Public route is attached. Okay, similarly for the private subnet, we need to do the association. Private, private, and then private route. Now that's it. You can check private subnet. When you go to route, you can see here NAT gateway is attached to the route table. So this is what we did manually in the console. We automated through Terraform. Now I can do Terraform destroy. Yes. So now all the resources will be destroyed with single command. If you want to destroy manually through the UI, you need to understand the dependency manually. First, you need to delete the NAT and you should come from the back. So creation is from the start, deletion is from the back. So that is very difficult to create and then delete with proper dependency knowledge. And that will take a lot of time. Okay. And a lot of efforts also. But here with single command, it is destroying everything. Now, after that, I will create with single command, it will create everything. So generally what you do here, you come and check create subnet, and then you have to search what are the VPCs, and then only you can attach. But here you are not doing anything, everything you are referencing. Here I created VPC. I am referring this VPC ID wherever I want. Okay, I don't want to go into the console and fetch the VPC ID, and I don't want to give here. Terraform is automatically referencing the value from other resources. That is the advantage. You can see here, it is destroyed. Now let us create again. That's it. So you can do the cost optimization also, right? So what you do, what I do in my project, in my company project is at 9 p.m. or at 7 p.m. I switch off all the EC2 and RDS development instances. And every day 8 a.m. I switch on. So how I do this is I will schedule the Terraform, something in background in Terraform. I'll show you in future. I'll schedule something related to Terraform in the background. So at 7 p.m. automatically daily, I will switch off the development instances because developers, they leave the office by 6 p.m. So I will stop it by 7 p.m. And tomorrow before they come to office, I will switch on again. So here I am saving almost 13 hours of cost. That is happening through Terraform only. So this is the VPC we created today. And this VPC code, we will be improvising it. Okay, from next sessions generally. So all of you just don't think anything else. Just go and create the VPC infrastructure as we did today. Okay, and then tomorrow, slowly today, VPC is created. And next, for example, RDS, we will have different folders generally. So if someone sees here, all VPC related resources are in this folder, or RDS related resources are in this folder, and then all EC2 instances are in this folder, something like that. Right now, the code is really ugly. Okay, it is really ugly, but we need to understand the best practices slowly and we need to implement them. So you should practice writing like this first, and then slowly we will implement, we'll do the improvements. Now let us take few questions. Veera Praveen Reddy, Annam, you have some question?
Yeah. Hi, Shiva.
Yeah, hi.
Thanks for the nice session. And my question is, Shiva, related to the private subnet, Shiva. So
yeah, okay.
If you are keeping, so let's assume we are keeping some resources inside the private subnet. So traffic will be, you have mentioned that traffic is originating from the private subnet. I mean, inside the resources, whatever it is there. So we might be having the incoming traffic to the private whatever the resources in the private subnet, right? So that will be also happening through the NAT gateway, or how it is?
No. So we don't get traffic. For example, here this tier, right?
Yeah.
So this is the front end tier, facebook.com.
Yes.
So front end application should have public. So you can keep this one in public subnet.
Yes, Siva.
Okay. And you don't need to access backend applications. For example, Facebook uses PHP in the background. So these backend applications, you no need to access. Okay. Only this one will access. So what will happen here? Here you write the front end in public subnet. And in private instances, you will keep the backend.
Yes.
And we will have separate database also. For example, separate database subnet. And this is also private. You don't need to access the Facebook database, right? So this one will access the database. So traffic comes to the public subnet, like the HTML website, and this one will access this private, which is backend, and backend will access database.
Yeah. Here my question is, does front end will directly communicate with the backend, or does it going to access through the NAT gateway?
No, directly.
Directly.
Yeah, this VPC can access the resources directly.
Okay.
And we can, so this public subnet can access this private subnet, and we will have database subnet. We don't allow this one. We don't allow this one.
Okay.
And understood?
Yes.
So just come, let's discuss this example again.
Sure.
As a customer, you want to see the chef or not?
Yes.
No.
No,
you don't want to see the chef.
Don't want to see. Sorry.
Yeah. So that's why this chef is this backend.
Okay.
And you don't want to see the raw, what they are cooking, what are the items they are using, right?
Yes.
So these are the raw, this is the raw data, like SQL data. So as a user of the Facebook, you don't want to see, you don't need to see actually, you don't need to see what PHP is doing, what data, how data is stored. We just want to see this website only.
Okay.
So that's why we keep this website in public subnet. We keep all the things in private subnet. That is a security also, right? If you go and see how chef is cooking, how he's preparing, then you will cook in your own home. You don't need to come to the restaurant.
Yes, yes.
So that is security also.
Okay. Sure. And also you have mentioned the in the private route table, whatever we have created a CADR block as a, I mean, 0 point completely, I mean, universal one. So do we need to restrict over there also, or do we need to by default give only a complete route, whatever we have in the code, in the Terraform code?
In Terraform code, you need to mention CIDR. For VPC
the private route, can you please go to the private route?
Yeah, here. You mean it's okay.
Go in
NAT.
Yeah, NAT gateway.
Yeah, this one.
So here we have given CADR as a 0.0. It's right. So do we need to give complete one, or can we also restrict here also? I mean,
if you restrict here, 0.0. means it is internet.
Okay.
This is the representation of internet, right?
Yeah.
So for example, when you are running some EC2 instance, you want to do some installation of install git.
Yep.
So that git is an internet. Git
Okay.
package is an internet. So it should go through the internet through this.
Oh, okay. Got it. Thank you, sir. That's all from us.
Okay. Yeah. Yes, Vamsi Krishna Reddy, you have some question?
Yeah. Hi, Shiva, bro.
Yeah, hi.
Actually, I just have the same doubt, like why you are keeping that NAT in public subnet? Why? Because it's going to communicate with the private subnet.
Yeah, NAT should be in public.
Okay.
That because these things can access. Okay, private can access this one. So it is just like a bypassing, right? Instead of, for example, here what is happening here? How you are reaching the chef through the waiter only, right?
From public, you are going to get the private, that is through between NAT gateway.
So we are taking the help of someone in public to access the internet.
Okay.
That's it.
Yeah. Okay, bro. And one more thing, like you have created Elastic IP before creation of NAT gateway. What is the main use of that Elastic?
So that is the condition. Actually, NAT gateway should have the static IP. That is the condition.
NAT gateway should have the static IP. So you are creating Elastic IP before creation of this NAT gateway.
Yeah, correct.
So that is the static condition, right?
Yeah, that is the condition generally. So usually when you restart the EC2 instance every time, you will get the different IP address.
Yeah, automatically IP address would be changed.
Yeah. So since NAT gateway is already connected, we cannot use the ephemeral IP address. So that's why we are attaching the static IP.
Okay, bro. Last doubt. See, with one click of Terraform desktop, you are deleting all the instances you have created.
Yeah, correct.
At the same time, while giving Terraform apply, again everything got created with one click.
Yeah, correct.
But
because tell me.
But before you have created each and every VPC, subnet, route table, internet with all instances you have created individually, and then destroy means okay, it's got deleted everything, but apply it will again coming from starting.
See, I just want to show you all how can you create the resource one by one. Okay. This is the development, right? Once the development is completed, then it is your wish. You destroy, you create.
Okay, in real time, everything will be created on one slot. VPC, subnet, everything. Like
that's up to the developer. So if I ask developer to develop an application, he can write the entire application and he can test whether it is working or not. Or he can write simple like login page and he can check whether it is working or not. Then he will go and then add more things, right? So that's what.
Yeah. Okay, bro. Depending on the.
It's up to you. It's up to you, bro. You can create all the resources and then apply it. I just want to show you one by one.
Yeah. Okay. Okay. Thank you.
Okay. Yeah.
Thank you.
Monica Poturu, you have some question?
Hi, Shiva.
Yeah, hi, Monica.
My doubt is we are destroying entire the infra, right? If I
Yeah.
want to try only particular resource related to subnet or resource related to gateway, so is it possible to destroy?
Yeah, it is possible. It is possible.
Okay.
Just let us search Terraform to destroy particular resource. But this situation will not occur usually.
Okay.
You can do that. We will see. You need to just pass the target, which one you want to destroy. That's it.
Space. Okay. And one more doubt, one more query is when you are using the command Terraform apply, does that go step by step or like how it goes? So now we have already created a subnet main, and VPC is the first resource which we have created, right? So
Yeah.
then we have given AWS subnet as the first one. So is does it go step by step, or like how the Terraform apply command goes through?
Yeah. So first, there is something called Terraform state. So I'll discuss in tomorrow's class.
Okay.
So this is the one actually that I'll discuss in tomorrow's class.
Sure. Not got it. Okay, that's for an existing infra, if I want to do some changes, so is it the one we need to do the code changes using Terraform, or do we need to use any other scripting like Ansible or something?
No.
Okay.
See, I created now. If I want some change, for example, I want to change the name of this one.
Okay.
And you changed it, and you just come here and then do Terraform plan, and then you will understand what is the change you are going to do.
Okay.
Okay, it is saying two changes.
Okay.
One change
So
is this one. Okay, it is changing from automated internet gateway to automated some change. And usually you don't know if you do some change, what are the other changes, because we have all the resources dependent on one each other, right? One resource is dependent on another resource. Then Terraform will intelligently identify you are doing this resource change, then there is another change is happening because of that.
Okay, any dependent resource will get affected. Okay.
Yeah, so you need to be like smart. I'm doing this change, then what change this, what change, what is the effect of this change?
Okay.
So if you are changing the internet gateway name and it is doing something different one, this is affecting the private route also. But that is not a problem actually. If you just apply, it will take care.
Okay. Sorry, like I have one more query. Like this is not up to the topic. So, what is the use of Ansible? Like how Ansible and Terraform are different?
Okay, so Ansible is only for once you create the EC2 instance, it can configure inside the softwares. For example, I want a big EC2 instance. Inside that, it is for Terraform is the infra provisioning.
Okay, for software management, we'll be using Ansible.
Yeah, infra provisioning is Terraform, like EC2. Can create EC2, but it cannot go inside EC2 and configure. It can do, but it's not. Its purpose is not that one. So Terraform will create EC2 and inform Ansible. Then Ansible will kick in and configure EC2. Simple difference. Okay.
So configuring EC2 means like any changes to EC2, like addition of S3 bucket or something like that, or?
No. Inside EC2, you want some packages to be installed. You want to harden the server, like you want to run some CAS benchmark hardening, and you want Java to be installed. So all those things it will do, Ansible.
Okay. Thank you, Shiva.
Yeah, most
That's it.
Mahesh, you have some question?
Hi, Mahesh. Hi, Siva.
Yeah, hi.
Till now, the topics was clear and I'm practicing.
Okay.
Apart from that, I have a small query. Yesterday, Today I practiced the lab what we did yesterday, but after applying the Terraform in it, so the file was downloaded and created that AWS provider file. It is nearly 300 MB, but I am unable to push all these files to Git, but I am getting a. How can I?
Yeah, good point, actually. Good point. So this one, .terraform folder, you should not push to GitHub. Okay?
Yes.
So what you should do usually is just like Terraform git ignore. Get this file. Just blindly copy the content. And you have to create a file .git ignore. And inside this, you need to paste that. Then Git will ignore to push this one. You can see here.
So no need to make any changes in the .git ignore file.
You need to have this file in your repository.
No, what I am saying is, I will get the .ignore file from it, but no need to make any changes in the file. Same.
Yeah, you don't need to make any changes. It's by default. Like, so whatever the Terraform files needs to be ignored, it's already written here.
But it is not working, Siva, because actually in the D drive, mine was a Windows laptop. So in the D drive, so I have created a folder. So IDE, in that IDE, there is a Terraform folder, but there is another, in the Terraform folder only, this provider file got downloaded, but I am unable to push it.
You should not push it. That's what I'm saying. That's what I'm saying. You should ignore this Terraform folder through .git ignore. But anyhow, I'm not, this session is not about pushing the files to the remote repository. Okay. You just research on it. You should have some git ignore file. Okay. And this is ignore. .terraform you should not push this .terraform to the remote repo. So that is the whole intention.
Okay, I just need to run git ignore.
Yeah, that's it. No need to run. Just have this file. That's it. Have this file, and then what you should do is git rm-rf .terraform. Okay. Usually you should do like this. Then it will remove that whatever you have. Okay, whatever you have already, then it will remove.
Then I will push.
Okay. Yeah, since I did not add this, then I'm getting it's not there.
Okay. Yeah. Okay. So
if you want if you want to understand the Git basics, okay. So we have in our channel, there is a playlist. It is in English, Git live free sessions, right?
So sometimes what happens is I'm pretty familiar with the big things, but these kind of things I will mess up with this small kind of things.
Okay, yeah, but this Git, whatever I taught here, it is completely different. Okay.
Yes.
So once you watch these sessions, you will change your opinion on Git.
Is this free or is it on YouTube?
Yeah, it's free. It's on YouTube. In 2019, I just posted in YouTube. Okay. So these are really how Git works in background. If any one of you are developer, DevOps, and cloud engineer already, you watch these sessions. This will change the opinion you have on Git. Okay.
Okay, Siva, one more thing, I did Ansible and Red Hat and OpenShift certifications in the past.
Okay, anyhow, so it is the session. This discussion is becoming lengthy. We can connect later. Okay.
Oh, okay. Thank you.
Yeah. Kiran, you have some question? Sairam Krishna, you have some question?
Yeah, hi Shiva.
Yeah, hi.
Suppose if I want to replicate the same infrastructure in 2-3 AWS accounts, generally organizations will maintain multiple AWS accounts, right? So in such a way, how can I manage the AWS CLI credentials? Something you have shown yesterday.
Yeah, so this is advanced topic, whatever you are asking. Yeah, we can discuss later. You will have here the account name as well.
Okay. So in the same file, we can manage multiple accounts and multiple regions.
Yes, correct.
Okay then. Thank you, Shiva.
So we can stop till here. It's already 1.5 hours. So ideally, I cannot answer each and every question. We can have some Q&A session on weekends. Okay. So, but you should do the practice. Once you do the practice, your questions and queries will be automatically resolved. And we can have this one already. From today onwards, I will be active in this community chat. If you have some errors, anything, you can ask here. So ideal way is just do a simple Google search. If you are not able to find the answer, you can post here. Okay, I'll be active from today and tomorrow onwards. Then I will answer your questions and we can have a Q&A session on particular weekend also. Okay, you can share your screen. If you are really not able to moving forward, then we can resolve your errors. Okay. Yeah, thank you so much for today. We'll see you in tomorrow's session. Have a nice day. See you. Bye-bye.